Let us now start the demo part. For this, you need a Microsoft Azure subscription and a browser, that's all. So let me log into this Azure portal. So this is my Azure portal. So first we're gonna begin with the Azure services for the machine learning. So let me click on the machine learning. I just click on add and then I need to type the machine learning here. So once I click there, the machine learning will open up like this. Then you need to click on create. So this will begin the process of creating. Here, this is my subscription, and then I will provide my resource group over here. So this is the selected resource group I have. Afterwards, I'll provide the workspace name. If you remember in the module 1, module 2, we discussed the workspace. Under the workspace only, we'll be creating all the resources like compute clusters and everything, inference cluster, attached compute. So we need to specify like which workspace it will be. So I'm just giving the workspace name test demo 066. It says that it is available. Then I'm selecting a location. East US will be fine for me. Then the workspace edition, I'm going to use basic as that is the cheaper one. Then I click on next, adding the tags. If you would like to add the tags, you can add the tags. That will help you to identify your resource. Then next, review and create. This will create your machine learning resource in Azure portal. So let me hit create. Validation has been passed. So this is my resource and it is going to create my resource for the machine learning, and then we'll begin the activity. For now we are looking for the automated machine learning model. Like I'm gonna use the Microsoft Azure Learn documentation, and from there I'm gonna use the data from which is available freely. So I'm gonna use that data and we'll feed that data into our machine learning model. And then when that's just completed, we're gonna use that thing to you that train the model. So for now, what we are doing, we are like first compute resources has been creating. Now, because when you create the workspace, the compute resource and all will be created on the machine learning. So what we're gonna do, we're gonna use the data for the bike rentals. So I'll tell you the concept of this. So in this Microsoft Learn, what example has been given is based on the bike rentals, like every day the weather changes, right? So based on that, the bike rental will affect. Let's say today is like a much hotter day. So in a hotter day, usually people don't take bikes. In a normal day, like it's a weather season, it's a good weather, a cool weather, then the bike will have a advantage, like then the rental will increase. So based on this data, we will identify or predict that on the coming days how the rental will be. So, for example, let's say today's weather is 40 and we have a rental of around 500 bikes, and tomorrow the weather is 28, so the bike rental increased to 900. So for the coming days it will predict that how many rental will be in our coming days. So based on that, we're gonna predict that. So let us check the so our machine learning model has been created up. So let us go back there. So this is our model for the machine learning test demo 066. It will look like this. So once it is created, uh, we're gonna we're gonna open that module for the machine learning. So let us open that. So now I'm gonna open that machine learning studio. So for that, there's a separate portal for that. So for that, you just need to click on overview, which is the main page, and then you need to click on launch now. When you click on launch now, it's gonna open that the machine learning portal. So for the machine learning portal, it is signing me in. Then I will be doing the activities. It's a separate portal than machine learning. So we're going to use automated machine learning. And based on that, we'll fed the data of our bike rentals and predict the value. So in here, it is asking me to provide the directory and the subscription, which we're going to provide. And in that directory and subscription, the machine learning will be created up. So let us add that value now. So I have added the directory and the subscription in here. Then I need to give the workspace name. Either I can create a new workspace or I can use the workspace which I have created in the Azure portal. Mostly I will use that only because that is one for will be used for my demo, that is test demo 066. So now let us click on get started. So it's loading the workspace. Let us wait for a minute or two. After 20 seconds, this page, I am seeing this page. So this is start tour and all. So for now, I will be working on the model for the automated one. So this is your machine learning page will look like. You can create a notebooks, automated ML and design a preview. So that this designer which we discussed the pipelines, we're going to create the pipelines over here. And the automated machine learning is like automatically the model will be getting trained when we use this model. So first let us see the computes which we discussed. There are four computes we discussed in the session. So let us discuss that first. So I clicked on compute. So if you remember, we discussed the compute instance, compute cluster, inference cluster, and an edge cubed. So compute instance meant that workloads will be running on this instance. Compute cluster means if you would like to scale up and scale down, then this is the place for you. Like if there's a more load, then we're gonna use compute cluster. Inference cluster, if you would like to deploy your application to AKS for large scale inferencing, then we're gonna use inference clustering. Attached compute is a place when you have a lot of data in your SD Insights cluster or Databricks cluster. Then you're gonna use the attached compute. So this is about the attached compute. Now we're going to create a compute instance because if you don't have the compute instance, then you won't be able to run the workloads. So let us create a compute instance first. Click on create. We're going to give the compute name. Here we're going to give test demo 066 because that is our name of the workspace so that we have the identification for that. So we're going to decide that which virtual machine you're going to use, CPU one or the graphic processing unit. Graphic is like for if you would like have to have that kind of requirement. For now we are going to use this. The next place is the virtual machine size. Here you can select the based on your requirement, but for now I'm selecting the cheapest one because this is for the demo purpose. So the cheapest one is this standard DS1V2, that is 0.07 dollar per hour. So I'm going to select that. In the advanced settings, you can like in here you can enable the HSS. In the advanced settings, you can set the virtual network also for that compute. So that will be lying in that network. For now, I'm skipping that and just click on create. So it will be created in a while, like in very few seconds, it will be created up. So it is creating now. So if you look at here in the compute cluster, we can have the cluster also created up for us. So whenever we require the like additional machines that can be created at that time. So let us create that also. So compute name, let us give the compute name as similar to our workspace name, and it's based on CPU. And here we're going to select the low priority virtual machine. Here it says the compute name is already exists. It should be unique. So we'll give it 666, or to have a good distinguish, we'll give cluster. Now we're gonna use low priority because low priority is the cheapest one. If you are using a dedicated, then it is that will be that cluster will be dedicated for you, and you will have a better holding on that as it is dedicated only for you. Now you can select the virtual machine. Again, we're going to select the cheapest one, which the cheapest one is 0.02 dollars, which we're going to select that. And after that, we're going to select what are the minimum number of nodes. For now, we're going to select one node, and maximum node should be two. That will work for us. This is a idle seconds before the scale down. Let us say that if you have a requirement of some like a lot of compute instances going on, and after let's say some amount of time, that instance is like that is not require much of the compute. So the scale down happen after 120 seconds. That is, if the node is idle for that amount of time, then the node will be scaled down. So we are setting this up and then click on create. After a minute or two, it will be created. So we'll see the compute instance. Okay, it's still creating. Let us hit refresh to see it's okay. So yeah, it will take some time to create that. Okay, so now let us move back to the home page of the machine learning. So this is our page will look like. So if you would like to use automated ML or a designer preview, which is in a preview, so you should have a enterprise. You remember at the time of creation we selected a basic instead of enterprise. So in order to make automated ML in use and a designer in use, you should be a enterprise subscription holder for Azure machine learning. It doesn't mean that you should have Visual Studio Enterprise subscription. It means that the plan which you select at the time of creation of machine learning, it can be basic or enterprise. So we should be enterprise for this. So you can upgrade that tier for that. Okay. So to upgrade, I'll go here and in this my Azure portal and I click on upgrade. So it is asking me to upgrade. You should review the pricing page. So I said, okay, confirm upgrade. So it is upgrading my workspace because if I don't upgrade, I will not be able to use this. So let us wait for a minute or two. It will be upgraded. Oh, it's upgraded. So let me refresh this. The workspace is now loading. So as you can see, the version has been disabled. Now I can use that automated and designer. So let us now start working on it. And if you see the compute instance and demo is loading, one is created and it is resizing to one. Okay, so now let us move back to the data sets. We're going to discuss each and everything. Here, data set means that your data, the data which I am saying that you need to feed that data, you need to feed that data to your environment. So this is the place where you're gonna feed that data to your Azure machine learning so that the model can be trained. So now, as we discussed, we're gonna use the Microsoft Learn document and we're gonna take that as a reference. So we're gonna discuss about bike rentals. So if you want to predict the bike rentals based on the temperature and humidity, everything, then I'm gonna use that URL and this the all the information is presented. So let me just show you how it will look like. So I have just opened that article. So here this is a raw data. So this data is not for any commercial use. Okay, this is mentioned in the terms and condition. You just need to your for demo purposes. So I'm using this data to only for the teaching purpose. So for now, I'm creating a data set for that. I'll use that URL and that URL, by using that URL, all the data which is presented in it can be feed it to this model and I can use that for my future uh, reviewing it and I can extract and I can do some analysis for my learning purpose. And you can also use that. So here we're going to use from web files or like any of the data set you can use it. So for now I'm using from web files that it is a web URL. So let us paste that URL. This is a URL which you can use too, as it is mentioned in Microsoft Learn article. So this is the data set. So in here, we're gonna name the data set. So here I'm gonna name it as test bike rentals. This is my name of the data set. And which dataset type you would like to choose, tabular or file. I'm gonna go with the tabular. You can add a description here. I'll say that to analyze data using automated ML. You can skip the data validation if you would like. It's up to you. For now I'm not doing it. Let's click on next. So now the data has been parsing to the dataset. Once dataset is been there, we can use our machine learning, and based on that we can use that data. So it is asking us to provide this schema. So it displays the schema which is presented over there. If you see here, the data is coming like this: day 1, year this, season this, holiday, weekday, working day. So all these things will be coming up: the temperature on that day, the humidity on that day, the wind speed on that day, and the rental, how many bike rental happened on that day. Based on this data we're going to predict. But one thing, if you notice that here the column 1, column 2 is coming up. We don't need that. We need instead day, month, year, season, holiday. So how to check that? Because column 1, column 2, no one knows that. We only knows day, month, and that became the part of the table. So how to correct that? To correct that, we're gonna go back and click on like cancel, and then we're gonna create this thing again. So instead of creating this thing again, what we're gonna do, here in at this page, see, we don't need that kind of data. We don't need column 1, column 2. Instead we're gonna use this column headers, and we're gonna use headers from the first line. So what it gonna do, it gonna move that headlines from the table to the top, and it's gonna use that. So let it load and we can see that. I'm pausing the video to see because it is taking some time. So now it is loaded up. So if you see that day, the column 1, column 2 has been replaced by day month. That is what I wanted. Now I'm gonna click on next. This is the schema which you would like to include or exclude. If you exclude any of the data, that column will be completely removed. And because you don't want to analyze on that, that's up to you. But for now I'm taking all the data in it. It is asking me to review that, and I reviewed everything and everything is fine for me. So now I'll click on create. It will take a minute or two to create that. If you see now, the data has been created. So now let me click on test bike rentals. So the data is presented over here. So it's just a data. You need to you need to feed that data to the automated ML. So, so to do that, we will now create the automated ML. So now we're going to create automated ML. So we have the data set. So I'll click on the automated ML because we are using this. So on this page, we're going to click on new automated ML run. Once I click on that, it will come like this. Here, I'm going to create a new automated run. So like this is a new automated ML run. For that, it is asking me to select a data set or create a new data set. But as I already have a data set, I'll click on this one and then click on next, because I have already created the data set for me now. So it is just uploading that data set. So here we will, in the automated ML, we discussed that there are experiments. So the experiments, we can perform a lot of experiments, and the experiments which you find that it is effective for your model, based on that you want to publish that experiment. So experiment is just a way of hit and trial. You are just testing it out with multiple data. So I am gonna select my, this is my name of the experiment. Target columns. Target column means this is the columns from the data set which I have given to that data set. So it means that if you read this, if you mean that it, which which field, which column you would like to predict. We would like to predict the rentals because we have the temperature. Based on the temperature, we would like to have the prediction of the at the rentals. So we're gonna select the rentals for now because I want the details of the rental, how my rental of the bike will be effective if the temperature is XYZ. So that's how, why I need that. So I wanted to predict the rentals, right, for my data set based on the temperature I have in my Excel. So I'm going to select the compute cluster, so which is demo cluster. So I'm going to show you the raw data again. So in this raw data, if you see day, month, year, season, holiday, and these are the temperature and rentals. So the last one is the rental. So I'm predicting this rentals based on these temperatures. Based on these temperatures, I will predict the rental. How will be my rental for the future year? This data is for like 2011. I can predict the data based on this year. I can predict for 21 or 22, 2020 or 2021 based on that. So this is how it will work. So this is a cluster. If you remember, we created the cluster and then click on next. So it is asking me which model I would like to select. Classification, regression, and the time series forecasting to predict the values based on the time. Here, if you remember that we are working on the numeric, we want the numbers. So the classification is based on the probability, that is yes or no, which is mentioned over here also and we discussed in the past. But here we will like to have the numbers as the predictions. So we're going to select the regression and click on finish because we are predicting the numbers. So this will take some time now. So once it is validated, we'll be having the ML for with us. So it is now loading and it is not started yet. Once it is completed, we can see that. So if you click on the models, all the models will be coming up here, which it gonna train. So let us wait for some time now. I'm gonna pause. Once this is finished, we'll be starting again. As you can see, now it is starting. Earlier it was in not in started state. Now it is in started state. And if you see the models, it's still not here. So after some time, the model should be coming up here. So as you can see, it's in preparing state now. But let it run. But for now, I would like to show you one more thing. So let us create one new automated ML because I wanted to show you the multiple scenarios. So let me create a new ML, and over here we'll use this bike rental. Click on next. The procedure will be same, but we'll select some different setting this time. Here it is asking us to give the experiment name. So we're gonna say that okay, we're gonna create a new one, new test bike rental experiment. Again, we're gonna select the target column as rentals. Select the compute cluster. We're going to select the same compute cluster. Then click on next. Here again, we're going to select the regression. because it's a numeric like we did last time. Now, the two settings which I wanted to show you now, there are additional settings. Let us see what settings these are. View additional settings. Here, the primary matrix is this. So based on this metric, it gonna do the enhancement, or it gonna fetch the data, or it gonna work on that. Based on this metric, it gonna work that. But the most appropriate for this model should be normalized root mean squared, because we want to have a normalized mean for all the data, because we are working on a lot of data. Like the weather is not a single, like we are taking the weather, we are taking the temperature, wind speed, humidity. So for that we're going to select for normalized root mean. So here we're gonna make that as check, like it will explain, it is a feature that will explain the best model, that automated ML will run a lot of machine learning models on itself. And if it's find the best accurate model, then it's gonna tell that, and then we're gonna deploy that model to our application. Here it is asking me which algorithm you would like to block. If we don't block it, it will use all the algorithms. So if for the first ML we haven't selected any so algorithm, so that ML will take a lot of time to build. So for now, I'll be using just two algorithms. That is a random forest and the light GMB. You don't need to understand these because these are just predefined. So I'm going to use these. Rest all algorithm are blocked. Here the exit creation. See, in this exit creation, this is a time set that is 3 hours. So the first one which I have created is will be working till 3 hours, and then I will get that result. But we don't have that much time. So why we don't have that much time? Because we want our model to be trained very fast so that we can have the results. And if you select as 3 hours, your model will try all the combinations from the weather, wind speed, and the rentals, and then it will give you the result. So see how effective it is. For now, we're going to select the minimum value, which is 25 hours, 0.25 hours. So 0.25 hours, that is 15 minutes. So it will take 15 minutes to build this to give the result. So I'm going to select that 0.25. Now it is asking me to add the metric score threshold. So you can select it any that what kind of guarantee you want in your model. It should be greater than 0. You can select zero point 0.9, you can select 1. For now I'm selecting zero point 0.8 or zero point 0.9 or anything you can select. This much of metric score threshold you would like to have. If this threshold reached by the automated, then it gonna stop. So the more metric you select here, the more time you would require. So let us click on validation. So the validation type is auto. You can select it any other, k cross fold cross, that I'm not gonna going into the depth. We're gonna select auto, and the concurrency also, like maximum iteration is 2. If the iteration is more than 2 multiple iteration, then it's gonna stop. So let us save and then click on finish. So it will take 15 minutes, but for the previous one we set the default values, so that will take like let's say 3 hours, because that's the default values. So let us build for this, and it will take at least 15 minutes. So I'm pausing this, and after that we're going to proceed. So if you can see that model is still running, so it will take at least 15 minutes, and now it is just 6 or 7 minutes. It will take some more time to complete running. So when you click on model, see it is bringing that model, it is running, so it will run multiple times and give us the result. So the status of this model is running, and this one is queued, so it will take some time to run. So let us discuss this algorithm which is already ran successfully. So when all the model is ran, it will be showing up at that place which you just saw. So it is run 5, and the model will look like this. So how you will analyze this, that if it's fit for your model, fit for your, or everything is fine for this. So you're gonna click on metrics. In the metrics, all the data you're gonna analyze it. So mostly like how you gonna use it, you're gonna use with the predicted true chart. So this chart, based on this chart, like you can select the multiple parameters, residuals, R2 score. So if you see here, these are the chart residual histogram. So what residual meant in the data science term is the leftovers, or you can say the residual means that the lesser the residual, the efficient the product will be. So it also means that the error, the last pointing error. So the like the it means that the error which is in the, like, let's say uh for let's say when you deploy the product, it is 1%, like it's 100%. When you deploy the, you want 100% prediction value, but the efficiency or the proficiency of that is 98%. So the residual is 2%, because uh, at the time of the results, it predicts accurately at 98%. So the 2% remaining is that residual. So that is the leftover, we say. So this is the chart you can see for the frequency and residually for, and this is our predicted versus true chart. This is the main chart which you would like to see. Here, the if you see the average predicted value, that is this. By this run, this run is completed. So by this run, if you see, the the blue line is like this, and the dotted line is the predicted value. Okay, or you can say the ideal one. So here, there's not that much difference, so which is good for you. So you would like to reduce that space between these two lines, because the blue one is the predicted value, and that dotted lines are the ideal. That is, it should be like this. So for that, if you think that this model is best for you, then you can deploy this module by clicking on deploy. But for now, let us check more models. Let us click on the models. So if you see, we'll see some more models in this. So as we ran for just 15 minutes, so due to that reason, there is very less models. So this is a model which is already completed. We analyzed one of the models. When you click on this, based on this algorithm, we have this model. And when you click on metrics, you can analyze this. We just analyze that if this chart is suits for you, then it is fine, and then you can deploy this model, because as per you, that the chart is fine because it is predicting the correct values. This is how the automated ML will work. You will set, we in this demo we set the time is 15 minutes. You can set it for like 10 hours, 5 hours, so that will predict more accurately. Then once you have a proper prediction, then you click on deploy. Let me name as deploy automated ML. Here you can use the okay, so it says that you should have no caps. Okay, agreed. So fine, this should now work. So compute type, where you would like to deploy AKS, that is Azure Kubernetes, or Azure Container Instance. So for now I'm selecting Azure Container Instance, and it's not a production. I'm also enabling the authentication, because I told you that once we deploy the Azure Machine Learning Automated Model, we're going to use it in our application by using the code and the key. So let us deploy that. So it's just a very easy way of doing that. You have the data, you fed the data in the data set, then in the experiments, you will you will analyze that data in the experiments. Once experiment you feel that it is fine, then you want to deploy it like this. Deployment started successfully. Here, the deployment started successfully. So now I'm going to show you the endpoints. The endpoint is the place where you can consume this. So if you see, we have deployed one of the applications and one of the automated ML, and the endpoint is created like this. Let us click on create. I click this. So we can consume this. So this is the all the information given over here. Okay. And now we're gonna consume this with our in our application. So it says endpoint URL is not available yet. It is because that it is still in the deploying phase. Let us wait for some time and this should be coming up. So I'm pausing this because yeah, deploying of this will take some time. So let us wait for some time until it we can see this. As you can see that endpoint URL is not available yet. So let us check if the deployment is still going on. So we'll click on the automated ML and then we're gonna click on the ML, automated ML, which we created, that is new test bike rentals experiment. Then we click on the models. In the models, we have this. So here you can see the explanation. In the explanation, you can see the explanation which ML has to say about. Like this is a query, and based on that query, it created that explanations which you can look into it. That how beneficial it is created for you. So you can check that. But for now, I'm not checking that more. So let us click on the run one again, and let us check the deployments first. Let us click on this model. Once we are on this model, then we're gonna click on this, and if you see here, the deployment status is still running. So once this deployment is completed up, then only you can say when it is succeeded, then only that endpoint should be coming up. So as the deployment is still running, so see now it is succeeded. So now we can see the endpoint. So let us check the endpoint now. Let us click this endpoint for this deployment. Let us click on consume and see we have the endpoint URL ready. Now we can use this endpoint and this primary key to use in our application. Okay, so how are we gonna use that now? So I'll create a notebook. In that notebook, I'm gonna add some code. Okay, so in that code, we're gonna pass this applications. So in this notebook, we're gonna consume that deployed application so that it can be readily used. So I'm gonna show you how. This is my notebook, okay, and this is using this compute. See, I told you that in the workspace we have the compute instances. So everything, the workbooks, notebooks, and all which you are running will be running under this compute instance. So we need to write the code, but for now we are as we are using the Microsoft Azure AI document, so we'll take the code from there. So let us go to that deploy model as a service. In this, you can find this code which is based on the bike rentals. So now we're gonna just copy paste this code. If you have your own code, or you can use that. Okay, so one thing you need to take care that you need to save the file in correct extension, which I haven't did it for now. So let us set that in a correct extension, this file, and we're gonna delete this file. Okay, so let me just click on here and let us delete this. We'll create again. because the notebook should be in the particular extension. I haven't created that. So for that, just click on create. Here in the file type, you need to select the notebook. Click on create. So that will be added with IPYNB extension. That is the Python one. So now you need to just paste this code over here. And from this code, we're going to consume the application. So let me duplicate this tab because I also need that key. So let me just save this. Sorry, not here. So here, so let me go to endpoint. We'll consume that. See, because you already deployed, that's why we have the endpoint and the passwords. So you just need to consume by using the endpoints and the password which it has in your code. And once you have that, you can easily use this code in your application so that uh, it can be utilized. So okay, so okay, just a moment. So here I copied this, then I'm gonna click on here, automated, sorry, in the notebooks. Then under the notebooks, I'm gonna just copy this endpoint, and we should, that's a best practice, we should delete each and everything when you do the deployments. So that's what I'm gonna do, because else it's gonna charge you. So I'll be deleting each and everything after the deployments, after the demos. So that's why I cannot, I should not be charged more. So I copied this primary key, then I need to paste that in my notebook. So now this code should predict the weather, bike rentals for me. So this is the key which I added. So if you see, this is a sample data. This is the day one. If you look at the this is the same data. This is the same data which we saw in the raw GitHub. So if you see, it's the month, year, and day. If you see here like this, day, month, year, season, holiday, weekday, that's and rental and wind speed. So if you look here, it's the same thing: month, day, year. Then let me just scroll it here: day, month, year, season, holiday, day, month, year, season, holiday. So everything is similar over here. If you see in the end, it's rental, wind speed, humidity. So there is no rentals written it. Why? If you recall, when selecting the column, like which column you would like to predict, we selected the rentals. So here there is one column is missing, that is a rentals, because rental is the thing which we're going to predict. So if you see, the last one is a wind speed, humidity, temperature. So this is wind speed, humidity, temperature. So this is the place, and this is the values which this is the values for my this year, and I would like to predict the values. So for this is the one, and I have added the endpoint and key. Let us run this. So now it is running, and within a few minutes it gives the rentals, that this is the recommended rental you will have. So see, on this day I will have 572, on this day I have 405, and then so on. So let us now check the data. So if you see here, we have 572 405. Just remember two values: 572 405. So let us see that if it's really effective or not. Let me make it as 21, 21, 21. That is, I would like to predict the value for 21 instead of 2020. So that value, if you see, we have 572 and 405. Let us run it. It is run. So upon changing the year, it doesn't affect anything. That is fine. We understand that because every day the temperature might be like similar for the next year. So let us now change the other values to see, let us drastically change the value to see if it is effective or not. Sorry about that. Uh, okay, so now let me change this value to 9 and this one also 9. So I'm changing the last two value. So the last two value was wind speed and humidity. Here, this is wind speed and humidity. I changed these value drastically. So let's see the value changes or not. 572 and 405. So see the value changes drastically. So I can say that the model works fine. So this is how you can use the automated machine learning for your environments. And this is how easy it is. In the next demo, we're going to see more. Thank you for today.